Hi, today I'm going to start to talk about the vectors and how we work with the vectors in statics. As you know, we have forces in statics and the forces are vector and need to know how to work with them. Basically, there are two types of operation we are going to look at, and the one for which is more suitable for 2D and the one which is more suitable for 3D calculation. If I want to divide the calculation and the way we are going to handle the vectors, we have two types of that. Is the one, the scalar notation, and the other one is the Cartesian notation. And we're going to talk about both of them, how we are going to use them for calculation. So let's start for scalar notation. First, we are going to do, assume we have as the x, y, and we have vector f. The way that we handle the scalar notation is that we are going to project the component of f on x and y axis like this. So it's going to be fx, and this is going to be fy. Now, if we know that angle here, the angle here is theta, and this is the f, so the fx is going to be the value, the magnitude of the fx is the magnitude of f times cosine theta. And the same for y. Fy is going to be f sine theta. If we have the fx and fy and we need to calculate the resultant force from them, as we know that we are going to just say that the magnitude of f is going to be fx squared plus fy squared. And if we have fx and fy and want to calculate the theta, we're going to say that is tangent inverse fy over fx, absolute value of that. So this is how we are write the vector in the scalar notation. So we just bring it down, the component in the x and the component in the y direction, and the x direction is f cosine theta, and in the y direction is going to be f sine theta. But now let's look at how we are going to write that exactly the same thing, Cartesian notation. Now I'm going to just draw the same vector here. So we have x and y and the vector f. So if it's projection, or its component is going to be fx and fy on the x and y value. This time we write the vector as fxi plus fyj. What are the I and j? The I and j are the unit vector along x and y direction or axis. So I is the unit vector. It means that its length is 1 and it's along the x direction. The same thing for the j. J is a unit vector, its magnitude is 1 and it's along the y direction. So we are going to write it like that, the same as a scalar notation. If we have the vector written like that and we need its magnitude, again the same, its magnitude is going to be just the square of its component, and then add them all together and then take the square roots like that. And again, if we have the f written in the Cartesian format and we need the angle here, the same as there, the theta is tangent inverse fy over fx. So these are the two methods we are going to do all calculation. The one thing that you have to keep in mind, when we are dealing with 2D, which is majority of the work in statics are in 2D, this is how we are going to do the calculation. When we are getting to 3D and when we do the calculation in 3D, using the Cartesian method is going to be much easier. So the scalar is easier to do in the 2D calculation. The Cartesian is more easy to do the calculation in 3D analysis. So we have the scalar, we have the Cartesian. Now I'm going to show you how we are going to find the resultant force in either of these two method or notation. So assume we have two forces applied at one point and we want to calculate the resultant force, or in other words, we want to calculate if we add those forces together, what's going to be the result. So I'll put a very simple example there. So again, first I start with the scalar one and then I'm going to explain in Cartesian one. So we have the x and y, and assume we have f1 with angle of, for example, the f1 with angle of theta 1, and we have f2 with angle of theta 2, and want to see if we use the scalar notation, what's going to be the resultant one. So we know the resultant one. If we want to draw the parallel line, we know this is going to be the fr, the resultant vector, and this is going to be the theta, the direction of the resultant vector. But how do you do the calculation? One thing is that when we have when we are doing in the scalar notation, the very first thing we are going to do is find the component of each vector along the x and y axis. So here, if I want to do that, we project it. So it's going to be f1 over in x, and this is going to be f1 in the y direction. Same thing we are going to do here is going to be f2 in the x direction, and then f2 in the y direction. Now, if we want to see what's the, we are going to see what's the resultant component in the x and y direction, simply just add them together. So if the component of the resultant for in x direction is just simply add all the fx, so it's going to be f1x minus, because it has an opposite direction, f2x. The same for the y direction. The resultant component, the component of resultant force in the y direction, you just add all the component in the y direction. So it's going to be f1y plus f2y. So both f1y and f2y are in the y direction, the positive y direction, so we add them together. But here f1x and f2x are in the opposite direction, so we subtract the other one from this one. So these are our component on the x and y direction. And if we need the magnitude of the fr, so its magnitude is going to be sigma fx, so the square plus sigma fy squared, and then the square root of that. And if you want to know the angle, the theta is going to be tangent inverse of same thing, sigma fy divided by sigma fx. So in simple word, the way we are calculating or finding the resultant force in scalar method, that the first step, just find the component along x and y direction for each of the vector. The second step, just add all the x component together and add all the y component together. That's going to be your x component for your resultant force, and it's going to be your y component for resultant force. And then we can use either of these two equations to calculate its length or its direction of the resultant force. So now we're going to look at how we do this calculation in Cartesian method. So by do the same example for the Cartesian method. So here we are going to have our xy axis and f1 with angle of theta 1 and f2 angle of theta 2, and the resultant force is Fr with angle of theta. Same here, what we are going to do, that the first thing we are going to do is we are going to write each vector as into its component. Again, like what we have there is going to be f1x, f2x, f1 in y direction, and f2 in y direction. So f1 is going to be, the first vector is going to be f1x I plus fy1 j. But the same here for the second vector. So we have the second vector, f2 is going to be f2x I plus f2y j, and the resultant force, you just simply add them together, f1 plus f2, which is going to be, we just add each component, so add all the components that has the I together and all the component that has j together. So it's going to be f1x, and sorry, so f2x is going to be negative here, so I forget. So it's going to f1x minus f2x and I plus fy1 plus f2y j. So this is our fr. This is what we have for the fr. And if we need its like here, if we need the magnitude or the angle, the magnitude of that is, again, we just square each component, add them together and take the square root. So it's going to be f1x minus f2x squared plus f1y plus f2y squared. And the same, the angle, if we need the angle, it's going to be tangent inverse of the same here, fy1 plus f2y divided by f1x minus f2x. So you can see that here what we are doing, that we just write each of the vector first into each component as I and j, and then simply add them together. Just it gives you something like that, and then you can calculate the magnitude and the angle. Again, so we can see that this one is much easier if we want to do the 2D calculation. This one later on will show that is easier if we want to do the 3D calculation. Now let's look at the simple example how we are going to add two vectors together, or find the resultant vector of two forces based in the scalar and then the Cartesian notation. So assume we have similar what we had, so we are going to add x and y. I have two vectors like that. So the first one is 100 Newton, so it's the F1, and the F2 is 50 Newton. and it has the 30 degrees here and 15 degrees there. 15 degrees. So I want to find the resultant force for either of these two methods. So one thing we are going to do is that we're going to first find a component on each of them. So this one, the f1x, is going to be 100 cosine 50 degrees, and f1y is going to be 100 times sine 50 degrees. The same here, we're going to do that for the f2. So here the f2x is going to be, its magnitude is going to be 50 cosine 30, and in the x direction, so I'm going to write it down here, f2y is going to be 50 sine 30 degrees. So again, the first step, just find a component on each of the x and y axis. The second one, after we have that, so for the scalar one was very easy, just add them all together. So the resultant force, the component of the resultant one in the x direction, you just add all the forces in the x direction that we have. So it's going to be 100, so it's going to be 100 cosine 50 minus 50 cosine 30, which is going to gives us 53.29 Newton. The same for the y direction. So the component of resultant force in the y direction, just add all the forces in the y direction, and it's going to give us 100 sine 15 plus 50 sine 30. The result is 50.88 Newton. So that's the resultant force, its component in the x and its component in the y, and its magnitude, if we want the x magnitude, will be the square root of just square this plus square this. So it's going to be 53.29 squared plus 50.88 squared, and the square root of that, which gives us 73.68. The same for the angle theta is tangent inverse 50.88, 53.29, and the result would be 43.67 degree. So this is how we do the calculation in the scalar format. So we find the component of each vector on the x and y, add all the x component together, add all the y component together, and the x component of the resultant force is the y component of the resultant force. It's very similar method in if you have 2, 3, 4, just the same procedure, find the component and add them together. Now I'm going to show how to do the same thing but using the Cartesian notation. How we are going to do this calculation in Cartesian notation. So in Cartesian notation, first we are writing each vector as its component. So f1 is going to be 100 cosine 15 I plus 100 sine 15 j. f2 is going to be, its x component is 50 cosine 30 as negative I and plus 50 sine 30j. So that's the final. Now Fr, we just add them, F1 plus F2, and so Fr would be just add I component and then add the j component. So the I component is 100 cosine 15 minus 50 cosine 30 I plus 100 sine 15 plus 50 sine 30 j, which is eventually, if we do all the calculation, we're going to end up having 53.29 I plus 50.88 j. And if we need the magnitude of the vector, that's square each component and then take the square root. So it's going to be 53.29 squared plus 50.88 squared, which is going to be 73.68 Newton. And the same for theta, is tangent inverse of 50.88 by 53.29, which is gives us 43.67 degrees. So that's how we find the resultant force in scalar format and how we find the resultant force in the Cartesian format. As I said, again, this is the method we are using for 2D calculation. This is the method we are using for 3D calculation later on.